Really? Oh. Is that? No.
Okay, so let's begin. First of all, we understand that if two lines are parallel, they're going to have the same gradient. Okay, so parallel means they're not going to intersect on a two-dimensional plane, therefore they should have the same gradient. Well, that's great if I have it in y equals mx plus c form. So if I have two lines that are in this form, it's pretty easy to see if they're parallel or not. Okay, so if I have them in this format, that means the coefficient of the x term is the gradient, and all I have to do is look at the coefficient in front of the x, and if they're the same, they're parallel. Alright, because they have the same gradient. So that's easy. That's easy street. If they're in the different form of this one, we can't tell what the gradient is if it's in this format. For example, if I have something like 2x plus 5y minus 10 equals 0, I'm unable to strictly just look at it and figure out what the gradient is. So one way to figure out the gradient from this is through algebra and rearrange this equation to look like this, to y equals mx plus c. And then I'll show you a shortcut later. We can rearrange this so I get y by itself, and then I look at the coefficient, and that's the gradient. So let's do that with this one. I move the 10 over to the other side of the equation, and then I move the 2x over to the other side, and my last step is going to be to divide every term by the coefficient of the y, which is 5. So I'm going to divide everything by 5 to get y by itself. Okay, now that tells us a lot, because now I have my coefficient for the x term, and that's my gradient. Okay, so what I want to do is I want to look at the shortcut between getting the gradient right here without doing all this algebra and just looking at these two coefficients right here, because it's going to be the same every single time. So if I were to take this equation here, the general equation, ax plus by plus c equals 0, and solve for y, I want you to look at the relationship between what the gradient is right here and what these two coefficients are. And we can use that as a shortcut to find the gradient when it's in this form. Rearrange and get negative ax on the other side minus c. So that's my general form if I were to rearrange the equation to gradient intercept form. So that means my gradient will always be the opposite of the a coefficient divided by the b coefficient. And to do a quick example of that, if I just want to find out the gradient, so if I have an equation that's written in this form right here, and I just want to find the gradient without rearranging, without doing all this, okay, I can just look at the coefficients of a and b and do that trick right there. So my gradient for this, okay, and we will have to remember, is just the opposite of a over b. And I say the opposite because a or b could be negative. So if it's the opposite of a over b, that's going to be negative 4/3 is my gradient. Okay, and you could rearrange the whole equation to get it, but we're not too concerned about that just yet. Okay, let's go back to this problem. Here are the steps I'm going to want us to do for this one. First, we're going to write an equation for line AB. And this is a line AB, not a line segment. We're just going to assume it goes on forever in both directions. So to write an equation for AB, I just need two things. I need the gradient and a point on that line. Well, I'm given 2 points on that line, so that's not a problem. The next thing is just finding the gradient. And that's That's easy. Since gradient is change in y over change in x, here's the change in y, 4 take away negative 2, and here's the change in x, 0 take away negative 2. We get 6 over 2, which simplifies to 3, gradient of 3. So to get the equation, I start with point gradient form, which is, I call it point slope form, but I start by putting it into this, because now that I have the gradient, I plug these two coordinates in from one of these points on the line. And which point you pick for x1 and y1, you can pick either one. It doesn't matter which coordinate you pick. I'll pick this one up here because it has a 0 in it, and it might make it easier. I get that when I plug in my values, and I'm going to simplify it a little bit. I'm going to write it in a different form. I'm going to write it in y equals ax plus by plus c equals 0 form. So if I write it in this form, I'm going to have to do a little bit of algebra first. That's what I get when I expand the brackets over here. And now I just rearrange everything, and the only thing I need to rearrange is get that 3x to the other side. Okay, so that is going to be the equation for this line right here. And you can probably tell what the next question is going to be is write an equation, and this is achievement merit level. Write an equation for a line. I'll write it down. Here's the question that comes up. Let's write an equation of the line parallel to AB and through C. So the only thing you need to remember for parallel is that they've got the same gradient. Okay, so we've done most of the work already up here. We found the gradient. It's got to be 3. It's got to be same gradient as there. And I already have the point. So I'm all ready to put it into point gradient form and do the algebra to get it in to ax plus by plus c equals 0 form. So you need to remember that parallel means it's going to be the same gradient as that previous line. There's the general formula. Plug in 3 for m, and for these coordinates right there, we're going to use that one. So go ahead and do that if you want to. That's the expression I get when I expand that 3 through. Now I rearrange and get everything over to the left side of the equation. Negative 3x plus y plus 6 equals 0. Stamp of approval. And that's it. Okay? Same gradient, parallel to that line through that point. So next up is perpendicular lines.